organization will ever operate day in and day out with absolutely no errors. In fact, no person will ever live with zero errors. It is natural for us as humans to make errors and to make mistakes. This is why it is absolutely essential to the culture of an organization and to an individual that they understand errors are not the issue. It is when errors turn into defects that a real problem begins to exist. ZQC is different from the traditional quality improvement cycle in the sense that the do and check stages of plan, do, check are combined. This gives operators the ability to do and check at the same time, which ultimately prevents errors from transforming into defects. So, how does it do this? The zero quality control system uses 4 techniques to combine the do and check phases. We will introduce those 4 techniques in this module and look at the specifics of each of the 4 techniques later on. Those 4 techniques are source inspection, or inspection at the source. This allows operators to inspect materials and information at the gemba or where the work is performed. Instead of inspecting only sample lots, all parts are inspected. This is known as 100% inspection. Immediate feedback. The ZQC system attempts to provide feedback instantly. This essentially means that if there is an error, the correction can occur right away. The ZQC system also integrates mistake proofing or poka-yoke. These devices check products and information. This is also known as error proofing. While all 3 of these elements are critical pieces of the ZQC system, the first is arguably the most critical. Oftentimes, problems are evaluated away from the source. This can lead your problem solving down paths that may not be in the right direction. Dealing with the problem at the source gives you access to more information at the source. This will allow you to see what is actually going on. Let's look at each of these 4 elements a little closer in the following lectures. A quick Google of the word inspection, and we find that it is defined in one way as careful examination or scrutiny. In chapters 4 and 5 of the book Zero Quality Control, Source Inspection and the Poka-yoke System, Shigeo Shingo describes 3 different types of inspection: judgment inspections, informative inspections, and the method used in the ZQC system, source inspections. Judgment inspections compare products and information to a standard. If the product or information conforms to the standard, it is good. If it does not, it is bad. Judgment inspections are a great way to catch inspections before products and information leave a facility to go to a customer. Essentially, judgment inspections separate good parts from bad parts based on specific criteria. So, what's the issue? Because standards are generally written for complete products and information or at specific stages of production, the inspection usually does not occur until the parts or information are complete. This means that if there is a defect found, it is likely that it occurred upstream in the process, and not only is there no way of preventing it, you may never discover the information you need to identify where the actual issue occurred. Judgment inspections are considered to be a traditional inspection. Informative inspections are a bit different than traditional judgment inspection. Still considered to be part of the traditional inspection group, there are 3 types of inspections that Dr. Shingo outlines: statistical quality control, successive check of each product, and self-check of each product. Statistical quality control uses various statistical techniques to determine whether or not the materials or information being produced are acceptable. SQC does this by checking sample lot sizes after they are done processing. While this may provide feedback a little quicker than judgment inspection, it only checks a sample of what is being produced. With that being said, it does not ensure that 100% of processing is good. Another traditional form of informative inspection is successive checks. Successive checks are a form of inspection which allow people in the process downstream to inspect a unit or information that has been moved on to them from somebody upstream. This gives people all throughout the value stream the ability to catch defects and provide feedback. Like SQC, successive checks do not prevent defects, they catch them and provide information about the defect. The final form of informative inspection is the self-check of materials and/or information. Self-checks give people the opportunity to check or inspect their own work. This allows them to catch defects immediately before passing items downstream. With that being said, self-checks will give the operator feedback immediately if a defect were to occur. However, like the other forms of inspection, self-checks do not prevent defects from occurring, nor do they prevent natural human mistakes from happening. Of the three informative inspection methods, self-check of each product provides the quickest flow of feedback and information. The one major discrepancy with the self-check method is that as humans, we are bound to miss some of our own mistakes. As you can see, all three forms of informative inspection are indeed superior to the traditional judgment inspection. Informative provides feedback and collects information that can later be used to improve the process. However, it should be noted that all three forms of informative inspection catches the defect and does not prevent the defect. Preventing the defect from ever occurring is the goal, and this can only occur using source inspection. Source inspection inspects products and information at the source. This is quite different from the judgment inspection and informative inspection methods. Dr. Shingo teaches in his book Zero Quality Control, Source Inspection and the Poka-yoke System that source inspection accomplishes two critical components in any effort to achieve zero defects. It catches errors, and it provides feedback regarding those errors. These two components are critical in achieving zero defects as they give you the ability to catch errors before they turn to defects. Source inspection works in different ways to integrate the check and do stages of the traditional inspection model. It does this by using different methods to control the do phase. For example, when you enter information into a form and submit it, if you do not enter a piece of required information, the form will not allow you to submit the information. In addition, the form will oftentimes scroll to or tell you what you need to do to successfully complete the process. This do phase is stopped and provides information and guidelines at the source to successfully complete the form. In addition, you will notice that the form cannot be processed or submitted until it has all the required information and is done correctly. Another way that source inspection may work is by stopping a machine or line when a part is not set correctly. It may also trigger a warning light if a machine is not running correctly, or send a message to the operator when something is not working correctly. Source inspection is very effective when combined with the other three elements of the ZQC system: 100% inspection, short feedback loops, and quicker action, in addition, Poka-yoke. We will look at these three elements in the following lectures. If you had time, money, and other resources invested in making something, wouldn't you want to ensure that 100% of your investment was good? 100% inspection is just that, the act of checking or inspecting every single physical product or piece of information. Statistical quality control uses different sampling methods which do not ensure that everything being processed is good and does not ensure that the defect is prevented. Most organizations use SQC because they think that it may take too long to perform 100% inspection. With sensors and other techniques, though, this hurdle has long since been overcome. With the goal of zero defects in mind, this is important. Statistics in the form of control charts can show us whether or not a process is under control and do help identify processes that have variation in the output, but 100% inspection performed at the source maintains control of the process and prevents defects. It can even help catch an error and correct it before the error turns into a defect. 100% inspection also improves the feedback loop. Let's look at an example. Bottles are flowing down a line. They all complete the process and are inspected after the fact. Some of the bottles are found to be defective. Where in the process did the defect occur? That's a good question. A great deal of research and root cause analysis would need to be done to find the error back upstream. However, if the process was using 100% inspection, each bottle would be inspected right on the line. If a defect was found in the line, a warning light may pop up, or a marker on the bottle with a defect may occur to prompt a worker to go and dig into the problem. You could also use a control poka-yoke. If a bottle was found with a defect, this may trigger a stop on the line to bring the process into a more controlled review. Then the operator could look at the different aspects of the defect and conduct root cause analysis right at the point where the defect occurred and right on the bottle that had the defect. This would allow the operator to bring the process back into control. He could also correct the defect or the error that occurred. Now that we understand 100% inspection a little better, I'd like to invite you to ponder the following question. What challenges would I have to overcome to make 100% inspection happen today? If you want, you can write your answers on a piece of paper or share your thoughts with us in the course question or the comments section. You never know, maybe someone else has the same challenge that you have and could help them overcome with a little discussion. We'll see you in the next lecture. What does the word immediate mean to you? What does the word feedback mean to you? In the traditional informative and judgment-based inspection methods, feedback is delayed at best. In many cases during judgment inspection, the feedback never occurs. Not only does this make it difficult for errors to be prevented, it also makes it difficult to correctly identify problems. The quicker the feedback, the quicker the solution. In the case of the ZQC system, immediate feedback can often be achieved at the point of error or even before. How does it do this, you ask? The ZQC system uses different methods or systems that signal the users when a mistake or error occurs. This provides them with immediate feedback. In many cases, the signal can occur before the item is actually processed. In our example of a website form, the information cannot be submitted unless all required items are complete. This immediate feedback occurs before a defect can. Another example might be an electrical plug with 3 prongs. If you try to put the outlet in upside down, it will not work. This is immediate feedback that you need to flip the plug over to proceed. That's immediate feedback. In the next lecture, we will look at one of the most powerful and well-known pieces of the ZQC puzzle, poka-yoke. Before you go though, take a minute to ponder this question. What errors or mistakes have I witnessed that, if found quicker, could prevent a defect? Feel free to share your thoughts, and we'll see you in the next lecture. Errors, mistakes, and accidents all can quickly turn to defects. As we've learned, the ZQC system, developed by Shigeo Shingo and shared in the book Zero Quality Control, Source Inspection, and the poka-yoke system, uses 4 different elements to achieve its goal of 0 defects. The 4th element is one of the most popular in continuous improvement, poka-yoke. Poka-yoke is a Japanese term that means mistake proofing. Poka-yoke devices essentially help facilitate 2 very critical aspects in preventing errors. They help accomplish 100% inspection. They also provide quick and almost immediate feedback when errors do occur that helps an operator take corrective action before the error turns into a defect. In the simplest form, a poka-yoke will either shut down a process, machine, or line when an error occurs, or signal the operator. The most effective poka-yokes are achieved with source inspection. However, poka-yokes can also be effective with informative inspection methods. Keep in mind that the informative type poka-yoke checks only after the defect or error has occurred with either the successive check or self-check methods described earlier. While this is effective in stopping the defects from traveling, it is not as effective as a poka-yoke at the source. Now that you understand what a poka-yoke is and the basics of how they work, we're ready to discuss the how of poka-yoke and begin preparing you to implement poka-yokes on your own. In the coming lectures, we will look at how poka-yoke works, the different types of poka-yoke, various sensing devices, and we will challenge you with a few reflective questions. With that being said, we'll see you in the next lecture.